Welcome to This Explainer. Today, we're unpacking the invisible magic that actually makes modern artificial intelligence possible. You know, we marvel every single day at these massive language models generating complex code in seconds, or multimodal systems seamlessly analyzing video streams, but we rarely look at the orchestration that's actually holding it all up.
So, to understand why this orchestration is absolutely critical, I want you to imagine something for a second. Imagine you launch a brand new AI assistant. At first, everything is humming along perfectly. A few power users are running complex agentic workflows, maybe doing some heavy RAG queries, retrieval-augmented generation against your database. The backend handling the load without breaking a sweat. But then, your app goes viral. Suddenly, millions of users start hammering your system with heavy compute requests at the exact same time. What happens next?
Okay, let's dive into this. Our expectation is always that we'll enjoy this perfectly smooth scaling, right? Just a tidal wave of happy users flooding into our brilliant new tool. But the reality is, it's far more brutal. When millions of users hit an unprepared system, GPU memory maxes out, resulting in catastrophic out-of-memory or errors. Latency spikes from mere milliseconds to excruciating minutes. API gateways completely buckle under the sheer volume of connection requests. And eventually, the requests just fail entirely. It's a visceral, system-wide crash.
Section 1. Meet your cloud operating system. So how do the giants of the tech world actually prevent this? Well, they rely on Kubernetes. Kubernetes is an open-source platform that automates the deployment, scaling, and management of containerized applications. It really acts as the hero of our story today, stepping in to bring absolute order to the chaos when a viral hit would otherwise crush a manual system. You can basically think of it as the ultimate operating system for modern cloud infrastructure. It manages clusters of machines, so developers don't have to. Instead of engineers frantically trying to manually provision new machines during a massive traffic spike, this platform completely takes over the heavy lifting. Kubernetes utilizes a highly intelligent scheduler. It acts almost like a master Tetris player, automatically deciding exactly where your containers, which are often called pods, should run. It intelligently packs these workloads into available nodes to maximize your super expensive compute resources. It ensures that CPU and memory are allocated efficiently, and crucially, it automates the recovery from inevitable hardware or software failures. It's essentially a fully automated command center.
Section 2. Managing massive AI resources. We really need to talk about why this is uniquely critical for artificial intelligence. AI applications are entirely different beasts compared to traditional web software. I mean, a standard web server might just need a fraction of a CPU and a few megabytes of RAM. But AI, LLM inference requires massive amounts of VRAM. Training and running these models demands ultra-low latency, high-bandwidth node-to-node networking, often using specialized hardware like InfiniBand. Plus, the sheer cost of A100 or H100 GPUs is, frankly, astronomical. You absolutely cannot afford to just leave hundreds of these specialized servers running idle just in case you get a traffic spike. The financial burn rate would be completely unsustainable. Now, what's really interesting about this slide is how autoscaling elegantly solves the dilemma between soaring demand and saving money. Kubernetes utilizes something called Horizontal Pod Autoscaling, or HPA. When user demand spikes, the system is constantly tracking custom metrics, things like GPU utilization, latency, or message queue depth. Once a specific threshold is crossed, Kubernetes instantly creates additional instances of your AI service to handle the load. Then, as the viral surge passes and demand naturally drops, Kubernetes gracefully terminates those pods and removes the unnecessary underlying resources. It ensures you have exactly the computing power you need during peak hours and drastically scales down, sometimes literally to zero when you don't. That saves thousands of dollars an hour.
Section 3. Keeping AI chatbots alive.
Now, scaling up to meet demand is a massive benefit, sure, but absolute reliability is just as critical. Let's set up a highly specific, high-stakes scenario. Imagine an enterprise customer right in the middle of processing a massive, complex batch of tokens for a critical financial document analysis. It's a very heavy workload, tying up significant compute. And right in the middle of that generation, a node simply drops. Just a hard, unpredictable hardware failure on the physical server racking the GPUs.
Without an orchestration layer, you're looking at an immediate outage. That enterprise customer gets a failed request, the application throws an error screen, and trust in your platform is instantly broken. But with Kubernetes, it relies on a continuous loop of liveness and readiness probes. Within seconds, Kubernetes detects the failed health check from that dead node.
It instantly removes the failed pod from the network traffic routing, ensuring absolutely no new requests hit that dead zone, and seamlessly spins up a replacement container elsewhere in the healthy cluster to take its place. This self-healing transition is so fast and so automated that users often never even experience a hiccup.
Section 4. Unifying complex AI systems.
And this brilliantly illustrates the reality of building modern generative AI tools. You are almost never just running a single isolated model. Let's map out the sprawling web of an actual AI ecosystem for a second. A single user request hits an API gateway, which routes to an orchestration framework like LangChain or Llama Index. That framework might first hit an embedding model to vectorize the prompt, then query a vector database, like Pinecone or Milvus for semantic context. Then it retrieves that data, packages it, and finally sends it to the LLM inference engine. Meanwhile, Redis is caching responses, Kafka is managing data pipelines, and Prometheus is logging all the traces. It is an incredibly intricate microservices architecture.
This is where Kubernetes truly shines as the ultimate orchestrator. It brings all of these disparate, highly complex components together into one unified platform through a concept called declarative configuration. Engineers simply write a YAML file detailing what the final healthy ecosystem should look like. How the vector DB connects to the inference engine, what ports are open, exactly how much memory each piece gets. Kubernetes then takes that declaration and continuously runs a control loop, constantly working to maintain that exact state. So instead of managing 6 totally independent systems, you manage one cohesive entity.
Section 5. The future of scalable AI.
The ultimate payoff for all of this architectural complexity is developer velocity. By completely automating the heavy lifting of deployment, scaling, and self-healing, Kubernetes frees up human ingenuity. Engineers actually get to focus entirely on building better AI products. They can dedicate their sprints to improving model accuracy, refining the user experience, and testing new agentic frameworks, rather than waking up at 3 a.m. to manually restart a crashed server or trying to write custom bash scripts to handle a random traffic spike.
Which leads us with this crucial question to close out our explainer today. As an entire industry, are we focusing a bit too much on building smarter models and not quite enough on the scalable, resilient systems required to actually run them in production? The future isn't just about the raw intelligence of the AI itself. It's about building robust architectures that can survive the unpredictable real world, recover from inevitable hardware failures, and serve millions of users with absolute reliability. So keep that infrastructure in mind the next time you interact with a lightning-fast, perfectly smooth AI tool. Thanks so much for joining me to unpack this, and I'll catch you in the next explainer.